Okay. Example 14-4, loudspeaker. The cone of the loudspeaker oscillate in simple harmonic oscillator at a frequency of 262 Hz, middle C. The amplitude at the center of the cone is 1.5 times 10 to the minus 4 meter, and t equals 0, x equals a. First question, what equation describes the motion of the center of the cone? B, what are the velocity and acceleration as a function of time? C, what is the position of the cone at 1 millisecond? So let's just start with the number A. So amplitude here already given 1.5 times 10 to the minus 4 meter, and the omega angular frequency is 2 pi f is 6.28 radian times frequency is 262 hertz, so that is 1650 radian per second. So with these two parameters, you can define the equation of simple harmonic oscillator of displacement function, which is the maximum amplitude times cosine omega t. So that is 1.5 times 10 to the minus 4 meter cosine 1650 t. That's number A. Number B. Now we want to estimate the velocity. We got to just estimate the velocity and acceleration as function of time. Already I just explained how to derive the formula of velocity and acceleration from the displacement of simple harmonic oscillator. So the maximum velocity is, that's maximum velocity equals omega A. That is formula I derived last session. So that is what? 1650 radian per second times 1.5 times 10 to the minus 4 meter. So that lead to the number of 0.25 meter per second of velocity. Or if you plug them into the formula of velocity of simple harmonic oscillator, then velocity should be minus 0.25. Let me just write down the formula of velocity out of simple harmonic oscillator. So that is the omega A sine omega t, right? So if you plug the numbers, then that should be minus this omega A itself is a maximum velocity we drove, so that should be 0.25 meter per second sine 1650 t. That is velocity in time. And also acceleration, maximum acceleration should be omega squared maximum displacement of simple harmonic oscillator. So omega is 1650 radian per second. You square it and multiply displacement, maximum displacement. So 1.5 times 10 to minus 4 meter. So the maximum acceleration out of this definition is 410 meter per square second. So now if you plug this number into equation of acceleration from the simple harmonic oscillator, then that should be A maximum acceleration times cosine omega t. Here, this one is maximum acceleration should be defined by omega squared times A. We already just derived the answer of omega squared A. So we just need to plug that number into this formula. Then acceleration in time should be minus 400. Oh, that should be minus sign in front of that. Minus 410 meter per square second cosine 1650 t. Okay. Okay, and number C, what is the position of a cone at t equals 1 millisecond? So that C, have plug this t 1 millisecond into displacement equation of simple harmonic oscillator. So let's plug that. So now formula of the simple harmonic oscillator displacement, then A cosine omega t. So the A is 1.5 times 10 to the minus 4 meter maximum amplitude. And now you're going to plug 1650. And now you plug this 1 millisecond into the t, then that should be 0.001 second. So you plug them all into this formula, then that lead to the answer of this number C question, which is 1.2 times 10 to the minus 5 meter. So after 1 millisecond, this simple harmonic oscillator will have 1.2 times like 12 meter displacement from the starting point origin. All right, so that's the answer for this 14-4 problem.